actually really clever though. So what it is that this is the AC cord here. So it comes in, and this is the transformer primary. And the transformer primary is wrapped around this ferrite block assembly, but it's actually then that this ferrite block actually connects directly into part of the motor apparatus. It's basically serving as a casing, and I think part of one of the static or one of the magnets. Like,
yeah, the thing's moving when you touch the.
Yeah, so that is the motor core. But it's actually, so this right here is the core of the motor.
All right.
And you can even see part of the copper windings for like extra power basically. But the transformer core and part of the motor assembly are a single ferrite.
What's that mean?
So a ferrite is basically a chunk of a ferrite core, it's basically a chunk of customized iron plating.
That's what I say. Ferrous means iron.
So, well, ferritic is a type. So, ferritic metal is a specific configuration of iron that is magnetic. But so what it is though is that this is a ferrite core. That it's laminated pieces of steel with a thin layer of insulation. And actually, you can even see. Well, actually, that's just part of the screwdriver. But so what it is that if you look very closely, you can see these thin layers. And what those thin layers are for is because that actually improves the efficiency. There's a thing called eddy currents, basically.
Okay.
That you use a ferrite core to control the direction of the magnetic field. It wants to propagate through the iron, so the iron wraps it around, keeps it magnetized on the actual block. But then what it is that as that field changes, it induces eddy currents, which are little electrical fields in places you don't want them. And so what making it into these laminated layers does is that each of these laminations are perpendicular to the direction that the current actually wants to flow. So the current wants to flow in a certain way, but it can't. It's hitting these insulated layered gaps. And so the eddy current can only flow in the very thin section of the actual laminated layer.
Okay.
And it significantly improves the efficiency of a transformer.
Aha.
But it's just the same assembly.
Okay, so increases the efficiency of the amount of power that it needs, or increases the efficiency of the work that it does?
It reduces the amount of extra electricity it has to consume to get the same current draw.
So more power with less electricity?
It's the same amount of power. The motor will do the same amount of power, but the transformer itself draws less total power.
Okay.
The transformer, okay, so transformers basically are a closed circuit on both ends. And they're, as far as the power is concerned, they're actually a short circuit. And so when there's no load on a transformer, there's still a little bit of current drawn here. But basically, the transformer here is its own little circuit. And so when you have the ferrite core like this, that part of the circuit wastes a lot less power.
Okay.
But basically, what was wrong with this thing is that inside of that chamber, there's the blade, and there's only one blade, and there's a little gap. You actually might be able to see it, where the shavings come out. So if I rotate it, in this little gap in there was this thing, wedged all up in the gear mechanism inside of the chamber.
How'd that happen?
It probably broke off of the back end of somebody's pencil when they jabbed the metal bit in there, and it got shredded up by the angry steel pieces in there.
Okay.
So yeah, don't stick metal into this thing, because this thing is made of better metal and it's gonna break it, and then I'm gonna have to fix it again. So don't.
Okay then. All right, it works? You are absolutely right.